83 and 84, looking at hydrates. Hydrates are ionic compounds, which we might call salts at home. And these salts have a specific number of water molecules attached to their crystalline structure. So a hydrate formula in the most general format would be shown something like this. The salt's chemical formula, big fat dot, and then an N number of water molecules. When the hydrate is heated, the water is pushed off, or it evaporates. So it leaves the salt's crystalline structure, and it leaves behind what we would refer to as an anhydrous salt. So hydrous referring to water, like hydrate, and means negative, so it means without the water, salt without the water. Usually the hydrated salt has a different color than the anhydrous salt. So here we go. So idea of going from the formula, so you're given the hydrates formula to come up with its name. So the first thing is name the salt. So match your symbols to the correct name. So use your table S and your table E. Think about if it's a polyatomic. If you have a transition element, then you may need a Roman numeral also in that name, okay? And if the anion may need to have its ending changed to IDE. So the elemental anion, remember, adjust the ending to the IDE. So things that we have always been doing. So that's the hardest part, is applying our rules, is match symbols to the name, use table S and E. If there's a transition, figure out if it needs a Roman numeral. An elemental anion, change the ending to IDE. Once you're there, match the value, what I have as N in front of the water molecule, to the correct prefix name. And then we replace the formula H2O with the term hydrate. Now, the prefixes. We know these. These are the Greek prefixes. So 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, like hexagon, 7 is hepta, 8 octa, 9 is nona, and 10 is deca. So here we go. So we have a chemical formula. This whole thing here is the hydrate, okay? So this whole big formula here is the hydrate. We have that big fat dot. What comes before the big fat dot? That is the salt, surrounded by N number of waters. So the first thing is to deal with the salt, right? So MgSO4. So the salt, I hope you realize it has a polyatomic ion. So Mg is magnesium. SO4 is sulfate. And carrying, and I don't, because this is now a poly name, I don't need to do any adjustment. Magnesium is group 2, no Roman numeral, so it's not a transition. So the salt's name is magnesium sulfate. Now I need to deal with the 7H2O. So the 7 is a prefix, hepta. So I put magnesium sulfate, hepta, and then we take this part, or we take this formula, H2O, and we replace that with the term hydrate. So it's heptahydrate. So magnesium sulfate heptahydrate. Okay, looking at the next one, I have CuCl2, big fat dot, 3H2O. The salt is the CuCl2. Cu, according to table S, is copper. Cl, according to table S, is chlorine, so it becomes chloride. Now, Cu, this is a transition. So we need a Roman numeral in the name to indicate the charge it's using. So Cu can use a +1 or a +2. Cl, as an anion, can only use a -1. So here we go. There's 1 copper. Which charge is it using? Plus, we have 2 chlorides. Each one uses a -1, so it's a -2. It needs to equal 0. What would you substitute in for x that you would add to -2 to make it 0? Well, the best fit would be the +2. So it's copper, Roman numeral 2, chloride. Now, when I take a look at this, in front of the water, I have a 3, which means it is tri. So copper 2 chloride, tri, and the formula H2O is translated into hydrate. Last example here, we have this hydrate, AuNO33, big fat dot, 4H2O. So when we take a look at this, notice the parentheses here around the NO3, so we know that that's a poly. So looking that up, we know that that's nitrate, and Au is gold. So we have some sort of gold nitrate. But when you look on the periodic table, gold is a transition element, and gold can use a +1 or a +3. So we have to figure out the Roman numeral that we need to have in this name. When you go and take a look at nitrate on table E, it uses a -1. So we do some quick math here. So there's only 1 gold, so which charge is it using? I'm just going to put an X. Plus, there are 3 nitrates. Each one uses a -1. So it brings a total of -3 equals 0. Well, would you substitute X with a +1 or +3 to add it to a -3 to equal 0? So the best choice here would be the +3. So this would be gold 3 nitrate. So that's our salt's name. Now we got to figure out the stuff for the water part. So we see a 4 in front of the H2O, so that means tetra. And we replace H2O with the term hydrate. So not a whole lot new here, just putting a couple of ideas together. So now if you're given the hydrate's name, come up with the formula. The hardest part is going to be the salt. So, match the name to the correct symbols. So you can use your table S and table E, whether one or both are elements or one or both are polyatomics. You need to then balance the charges. So you have to look up oxidation numbers and just so look up oxidation. So you can find for You can find, so you could use the Roman numeral if it's in the name for the cation. You can find an elements charge on the periodic table and a Pauli's charge on table E. And because the salt is ionic, the salt's chemical formula needs to be in the lowest whole number ratio because it's empirical. Once when you have the salt's formula, place that big fat dot after the salt's formula, replace the prefix with the correct value, and replace the term hydrate with H2O. So if I take a look at an example here, okay, I'm going to do one example. It's nickel 2 chloride. So the name of the salt is this part right here. This is the salt. So working through it, nickel's an element, symbol is Ni. It has the Roman numeral 2, which tells me nickel is using a +2. Chloride refers to chlorine, which is Cl, and that uses a -1. So when I use my crisscross method, I come up with the salt's formula as NiCl2. Next step, big fat dot. Now for the next part, I see this di, which means 2. So instead of di, I put a 2. And for that term hydrate, we replace it with H2O. So it's NiCl2 H2O. One more. So we have potassium chlorate monohydrate. The name of the salt is what comes before any prefix. So potassium chlorate. So looking up symbols, potassium is the element and it uses K. Chlorate is a polyatomic, which is ClO3. Oxidation numbers, potassium uses a +1. Chlorate, according to table E, uses a -1. Using that crisscross method, it's pretty much empirical. So my salt's formula is KClO3. Then I need my big fat dot. Now, out in front, I have a prefix of mono, which is 1, which I can write in or I don't need to. And then I have hydrate, which I replace with H2O. So this is potassium chlorate monohydrate. You could write in the value of 1 in front of the water if you like. One last example here. We have iron 2 acetate. Iron 2 acetate, this is the salt. Iron symbol is Fe. We have a Roman numeral of 2, which means it uses a +2. Acetate is a poly, C2H3O2. It uses a shared charge of -1. Use your crisscross to get the subscripts for the salt. 1 to 2 is empirical in nature, so the salt's formula is Fe in parentheses C2H3O2, 2 of those. Now adding on the water part, big fat dot. In front, after acetate, I see the prefix tetra, which means 4. So right after the big dot, I put a 4. And we replace that term hydrate with H2O. So my final formula is Fe C2H3O2, big fat dot, 4 H2O.